Cool.
All right.
I think I might be ready.
Are you all hooked up?
I am. Let's see if Linux will agree with the projector.
If you want to sit in the big papa chair, you can move that over. If you want to sit in the
driver,
you can stand.
I'm really fidgety, so if I sit down, it'll be bad news. Standing.
Okay.
Okay,
some seats.
Oh, we have chairs.
Pull in a chair.
Yeah.
Even if you want to sit in the middle there, just pull a chair up.
Cool.
I know I sit all day, so it's actually nice to stand it.
Cool.
All right.
It's a great logo.
That's exciting. So this is Will Blankenship. He's going to be talking about Docker and NodeSource. He's a consultant at NodeSource. Maintains several Docker images for them and for open source projects. So he's going to talk about Docker generally speaking and talk about what he has learned over time maintaining Docker images. So we're very happy to have him, and we'll turn it over to you, Will. Thank you.
So real quick, like this is gimmicky and people do it all the time and it bothers me, but I'm going to ask for a show of hands. Who's actually heard of Docker? Now, if you've actually used Docker, keep your hands up. Okay? And if you use it in production, keep it up. Wow, okay. I'm surprised. I was expecting all of them to go down. We'll need to talk about something. Sure. Excited to hear. All right, so what we're going to talk about today is for a quick introduction of what Docker actually is. We can skim through that since most of you seem to be familiar with it. And then we're going to talk about how Docker changes things. Because when you look at all the perks of Docker and everything, when you look it up online, people list all the technical reasons why it's awesome, but there's a lot of philosophy that comes with Docker that's really changing the way we do things, and it hasn't caught on yet, but you'll be seeing it happen more and more over the next few years. And then we'll talk about the actual title of the presentation, which is owning the stack and what that actually means. So yeah. So to read over like everything that she just said. So one of my slides.
It's a big gloss over.
Yeah. Who I am, first in the bottom right hand corner here, Blankenship.io. I've taken this talk and I've turned it into a 3-part blog post. So if you guys need like a text reference to it to like circulate at work or something, go on there. I have 2 parts that are released. I'll release the 3rd part tonight. Who I am, I work at NodeSource as a consultant. We do trainings and like in-house trainings or in-house consulting for Node.js. And everything Node.js. And we have some really awesome applications that we've built to help deploy Node.js in the enterprise and help keep your DevOps team happy and working really well with your developers. So check us out if you haven't heard of it. I also, so what I do at NodeSource right now, I'm focused really on some of the Docker stuff, which is really exploratory for us. But I'm maintaining, what the talk will be about, is I'm maintaining the official NodeSource Node.js and IO.js Docker images, which I think are filling kind of this void that the official images don't. And I kind of want to get some input back on that one. I also maintain the official IO.js images, or co-maintain them. And it's the work there kind of inspired some of the work I'm doing with NodeSource. And then I also maintain a Docker badging service. So on GitHub, you can put all your Docker stats right there on your README. It's a little badge right there. And I'm also senior at SIUC and graduating in 22 days. So I'm pretty excited about that. I can start doing this stuff full time. Yes, thank you. I'm already checked out. So owning the stack, we're going to talk about what Docker is real quick. So Docker is a really thin layer on top of things that have existed for a pretty long time and are getting more and more well defined. Most importantly, they are a layer on top of C groups and namespaces and IP tables. And the technology, IP tables questionably, but this technology is collectively known as Linux containers, LXC. And what that allows you to do is kind of, if you guys have deployed on virtual machines in production, it kind of lets you skip the virtualization layer and run programs in a shared environment in isolation. So IP tables isolates the networking or allows you to route networking between what are called containers, which would be your classic virtual machine, and kind of let you define what can talk to what and what can talk to the outside world and what the outside world can talk to on the host. C groups and namespaces allow you to isolate the process from talking to other processes on the server, and they allow you to isolate it within the file system itself. So you can isolate devices, you can isolate basically everything that shows up in in the or Unix file system, you can isolate to a process or from a process. So the process basically thinks it has exclusive access to that. And on top of that, it has AUFS, AUFS or overlay FS, and I think one other, Union FS, depending on which operating system you're running, is a layered file system which allows you to access many file systems at one input. So basically what they use that for is version control. So in a classic virtual machine, between cgroups, namespaces, IP tables, we've basically gotten most of the benefits of a virtual machine. AUFS is kind of a way or a unique approach to deploying the, I guess, what would classically be called the volume or the disk image for a virtual machine. We take a layered file system and we can deploy that. And then when we want to do updates to that file system, we only have to push the updates that have happened to a higher layer, or throughout lower layer updates and update them. So it allows us to push less over the network and still get an updated image on the network. So why Docker is awesome, we're going to do some live coding. I forgot I had this in here, so I'm going to sit down. So we have this thing called gimmick.sh. Oh, this is my blog, if you want to hop on there. I meant to show you this. Oh, I'm not online. Oh, well.
Want to get online?
No, I'm fine.
Okay.
So we have this script called gimmick1.sh. If you look at it, it's just a little simple for loop. It accepts an imager, and it starts up Mongo instances on your local host. So what we're going to do is we're going to run gimmick.sh, and we're going to ask it to start 25 Mongo containers. Each one of these is a unique ID of the container that it just spun up, and it's spinning these up in real time and having them listen on these ports. So you can see in a virtual machine, this would probably take 10, 15, 20, 30 seconds, depending on the size of the operating system. Then you'd have to boot the actual, depending on the virtual machine, then you actually boot the operating system itself, let it do its whole thing, if there's system D, et cetera, start with all the services. We're already at number 18, 19, 20, et cetera, et cetera. And what's actually happening here, let's cancel those, that's Docker PS. We actually started all of them. All quiet, type into XR, Docker around. Go ahead and clean them up. And Debian uses overlay FS, which is a little bit slower than AUFS. So a lot of these operations are taking a little bit longer. But if you're running a bleeding edge Debian system, or if you are running Ubuntu, most of these containers have sub-second start times. So you can spin up an entire service in less than a second, which is awesome. But we'll take a look at what these actual containers are spinning up. They're more than just the service itself. You're not containerizing just Mongo here. What's happening is, let's do docker run -it mongo du /. Oh, we wanted to do summary. -h. So what you can see here is we've actually packaged the entire Linux file system into this container. And when we spun up that, we're spinning up a unique image each time with its own operating system, everything, all the resources that it would expect to be there. The only thing that's not happening is we're not spinning up the operating system itself because it's running off the kernel on the host. That's the only thing that's that's the only thing that's actually touching is the host is managing it. But it has its own unique file system that it's isolated to. This isn't my host file system. And dpkg. And I'm using dpkg, so you should be able to, this is Debian. It comes with all the packages that you would expect to run Mongo already installed with it too. So you containerize the entire stack required to run Mongo, operating system and all, inside of this container, spun it up in real time, or well, near real time, so almost sub-second spin up times, which blows virtual machines out of the water.
Property files.
What do you mean?
Do you put them on? Would you put them in your? Would you deploy those with your container, or how would you do within your image, or how would you deal with those?
So by property file, you mean like a configuration file?
Yeah, they're told that you want to externalize everything, right? But do you have to externalize property files? Is it?
So it depends. If you're pushing something out to, let's say you're doing a Mongo image for your company, right? and you have an internal Docker repository that you're going to push to, or Docker registry inside of your company that you're going to publish to. It's probably not the worst thing in the world if you publish your configuration file internal to your company, right? But if you're going to push it out to the public registry because you don't have your own, you probably, Docker has these things called volumes where you can mount local folders inside of the Docker container. So the Docker container can actually get access to those folders. It would be a good idea to put them in there and let your Docker container reference that. And maybe have like a default configuration file in there, and if you don't mount it in, it'll just spin up a default configuration. That way, like your shared secrets and things like that aren't published on the public registry, if that makes sense. Yeah. And another cool thing is you can pass an environment variables on start. So, and like maybe you want to have a configuration file, and there's a lot of configuration things, and you want it baked in. You can bake that in, and just put all your shared secrets and environment variables, and pass it as an runtime. But yeah, it depends on the purpose. But, okay. Does that kind of answer the question?
Yes.
Cool. So there's 107 packages that got containerized in here. We're spinning up an entire operational. Spinning up is probably not the right word. Spinning up a container running Mongo with all the operating system dependencies and packages in there in just about a second, which is pretty impressive. So we can see the efficiency gains. So we'll talk about how Docker changes things real quick. And this slide will kind of be the 4 points that you generally hear when you go online and you look up why Docker is awesome. First, we'll do this one, the lightweight alternative to virtualization. We just showed Docker spinning up a bunch of containers, like 25 instances of Mongo in about 25 seconds. And what was interesting about that is we were running it all on the same host. In a virtual machine, I'd have to allocate like maybe 512 megabytes of RAM or maybe 50 megabytes of RAM. And if I hit like the home page on Hacker News, my server would fall over. So like, we have to allocate those resources up front, and if our service isn't using any of those resources, they're still being used on the host. Docker allows you to run like 25, 30, 40 services on the same server, sharing the same 1 gig of RAM if they're pretty much never used. And one day, if one of them gets slammed really hard, it'll be able to consume all the other, and you can have load balancing on the on a server above it, so you can spin up another service somewhere else if you want to elastically span out. But like, long story short is you can run a lot more services on the same server than you could with virtual machines. And then on top of that, you have the AFS layer file system. So what that allows you to do is when you're doing updates, instead of sending a 20 gigabyte disk image across every time you want to update all of your servers, you just push the deltas on your file system to the Docker clients, and they'll automatically do the update for you, which is fantastic. But the huge thing that you always see people talk about is the standardization of deployment. Standardization of deployment for Docker images. So what it basically says is that developers, for the longest time, when I was a new developer on a team and they had this really complex environment that they were working in, I would probably spend the first 3-4 days of my time on site running makefiles, running configuration scripts, installing applications, et cetera, et cetera, et cetera. And if I was a new guy on DevOps, or if we were bringing this new product in and DevOps had to figure out how to run it, we'd be handing all this over to DevOps and saying, hey, set all this up in a server somewhere and try to figure out how to make it secure, configure it, and get our code to run it. That's a pretty horrible environment to be working in. And with Docker, you can have a single Docker configuration script, and you run or composition script, you run Docker compose, and they can spin up any number of dependencies for you. So you can spin up 5, 6, 7, 8, 9 Docker containers, all with your complex Mongo, MySQL, Redis dependencies, et cetera, and replicate that entire environment without any like setup costs for the developer on the team or DevOps. So it's standardized as that deployment. So you're no longer working with configurations, you're working with containers, and anybody can run a container. It has really fast spin-up times, and the layered FS reduces update costs. So we have a bunch of technical reasons why Docker is awesome, but it's actually so much more than that. And that's actually what the core of this talk is about, is not the technical reasons why Docker is awesome, but the philosophical reasons why Docker is awesome. Docker represents a fundamental shift in the way that we think about development operations, and it's going to change the way that all of us do our jobs in the very near future, and it's going to be for the better. So the first paradigm shift, it's very similar to the standardization of deployment, but when people talk about standardization of deployment, they always talk about how awesome it is that I don't have to set up all these, like run all these make files, run all these configuration files. They never talk about the fact that this is going to do for the server what web browsers did for client-side code, is I can run, or I can write code for the clients, and as long as I target an evergreen browser, it's going to run in just about everywhere. Once I hit scale, I might have some few things that I'll have to tweak to work with like the edge cases and like Firefox or whatnot. But for the most part, it's just going to run everywhere, out of the box. I don't have to worry where I'm targeting. I don't care if it's an Android phone. I don't care if it's a old IBM. If it's running Chrome, it will run it. With this, any computer running Docker can run any Docker container. That's huge. And any Docker container can run on any computer running Docker.
You do know that half of that looks like a promised Java view.
Right, but it doesn't require a virtual machine. That's the big difference. The Java virtual machine.
Equals virtual machine?
No. No. If you've ever tried to run Monet and Jenkins on the same server, you realize really quickly why the promise of Java failed. When it eats up all the RAM and JVM like spews out some huge stack trace saying, hey, I can't allocate more resources and I'm just going to go ahead and shut down, there's a reason why Android's using Dalvik and not the JVM. Yeah, so
Can you share some resources between containers?
So all the resources are shared, so you don't have to allocate things up front.
Okay.
Right.
Don't you risk one container possibly eating up a bunch of resources that other things you need?
Certainly, but that's a shared environment. So basically, if like I deploy MySQL and Redis, and all of a sudden Redis starts consuming all the RAM, I should have a layer on top of that that's monitoring that and saying, hey, I need to spin up another version of Redis and load balance everything over here elastically in like whether it be in Amazon or DigitalOcean or et cetera, et cetera. But I shouldn't have to pre-allocate those resources up front until I realize that there's a D-Day scenario going on. Because all of a sudden with a virtual machine, like you may have something spun up. For the longest time I had Docker ICO running all by itself on a server because like in the event that I needed the resources, I needed to pre-allocate those resources. So I said, okay, I'm going to have about, I'll say that this never will require more than 1 gigabyte of RAM. So I put it out there so like if one day I hit the top page of Hacker News, that thing will not fall over. That's good. But that means while that virtual machine is running, unless I deploy something else inside of that virtual machine, like nothing else can use that resource. So it's nice if you have to maintain a service license agreement for your end customer. So if you're doing like a cloud service offering and you want to make sure that like one of your customers always has 1 gigabyte of RAM no matter what, that's awesome. But you should be managing that at a layer above it if it's for an internal private cloud, if that makes sense. Yeah. But yeah, I guess it is the promise that Java made, but I think it's more capable.
Delivering.
Yeah, it's actually delivering that promise. But this is the thing that the talk is actually about, and this is the thing that almost everybody misses. Solomon Hykes has talked about this at length, and this is really what's going to change everything. And this is stack as a dependency. And what that is who takes responsibility of the stack and what is considered a dependency. If you gave a developer a blank laptop, just completely empty hard drive, and you said, hey, go make this application, first thing they're going to do is install an operating system. If they chose to install, once you over Fedora, deployment is going to look very different for your DevOps team. Very, very different. With Docker, you capture that assumption. The assumption that the developer made that Fedora is going to be there in production, or Ubuntu is going to be there in production, is captured in the container. The file system is set up. Because the developer just says, I'm running Linux. And we pick which type of Linux we're going to run. Developer gets to make that choice. You don't have to pass that off to developer or DevOps to set that up. Next thing they choose, like, hey, I'm going to run Python. Python 2.7 may be very, very different, or 2.7.3 may be very, very different for your code than 2.7.2 or 2.7.4. You're making the assumption it's going to work on those, and very well it might. But when you're pushing out into production and like serving, hundreds of thousands of requests, like if you push out that new code because you decided you're going to update to 2.2 or 7.4 and it falls over, like that's a big deal. You've made an assumption that it's going to work on a very specific version, and that very specific version is going to be in production. Docker captures that in a Docker file. That's big, because what we're saying is the developer is now documenting along the way what is required to run his app, And when it's time to deploy it, we can pick up that little container that we put all these things together in, we hand it off to DevOps. And DevOps no longer has to worry about maintaining a system that looks identical to the developer's development environment and vice versa. All they have to care about is the fact that they're running Docker and they can spin these up. And that means they can focus more on getting code from the developer's laptop and out into production through continuous integration and making sure that they do that efficiently and doing that safely. So they can focus on what their job is actually supposed to be about and not just trying to maintain a mirrored copy of your developer's development. That's huge. So,
can you elaborate on what that CI would look like? Are you updating a template of the container?
So yeah, actually, I've been playing around with this a lot, and I had to put it on hold because of finance. So I've been playing around with this for the IOJS Docker, or for the IOJS containers, and what I had was Jenkins. Basically, it'll pull down the version, or it'll pull down the Docker file that you pushed into GitHub. It will build that Docker image, and it'll basically say, okay, so this is the Docker image that we're going to try to ship to production. It'll create another Docker file that imports from that, basically relies on that previous Docker container. Create another Docker file that contains all the continuous integration tests, relies on that, runs all the CI tests, is layers on top of that. And if those CI tests fail, that Docker file isn't going to build. And you know, hey, there's something wrong here. If the CI test passes, that Docker file, that container, that built, everything's okay. And then you can throw away all those layers you just created of tests on top, and you can actually ship the code base that you tested in the environment that you tested it in into production. That's cool. Mm-hmm.
Are you?
No, go on.
Well, are you building more? You're putting it into the container, or how are you have a template container that you have that has your JDK in it and all that other stuff? How would you do that?
So the idea was, so I guess rewind for the Docker files. Have you built from the Docker file before?
I know.
Okay, so a Docker file. Let's go off track real quick. And this is completely fine because that is a good question. CD Debian Jesse IOJS 1.3. All right, so this is what a Docker file looks like. It says from Debian, and this is the first thing that the Docker client will do. It'll grab this Debian or the Debian image from the public repositories, pull it down, and then the next thing is maintainer, and it creates a little tiny layer that says, hey, the maintainer's will. Then it creates a new layer, and it runs this inside of that layer. It says, hey, apt-get update, run all this stuff, and then it'll capture all of the file system changes, the files that have been deleted, created, etc., and it creates that into a layer. All of these get created into little tar files that get shipped up to the public registry if you decide to publish, or they sit on your file system. These get flattened down into a final image. And that image you can make as a dependency for another. So whatever I name this image when I build it, I can take another script and I can call from that tag, whatever I tagged it as, and it will pull in that image off my local host. If it doesn't exist on my local host, it'll go out to the registry and try to find one with that, pull it in. So what it allows you to do is you build one of these in your continuous integration server, you give it a very specific name, then your other Docker file will be a template file where this is a variable, and all you have to do is you inject the name that you named that other image into that, and the rest is your continuous integration test is run commands. Those run commands run. If they fail, just return 1 or a non-zero, non-truthy value, and that build will fail. And now you know, hey, whatever I just built, the continuous integration tests, they didn't pass. So we know we don't want to ship this. If it does build, we throw that new container we just built away, and we ship the original image out into production. Cool. Cool. We'll come back to this screen in a minute. All right, so what does owning the stack look like? And what I was talking about where all those dependencies are bundled together, I was playing around with version pinning because we wanted to ship Node.js applications, and when you're working with enterprise, there might be a very valid reason why you haven't updated to the latest version of Node yet, or you may still be on a few versions back. Maybe something isn't working, maybe there's a memory leak, or maybe your security guys told you absolutely no way you're updating this until something else is fixed. There's a very valid reason that version pinning exists, and a reason you may want to run an older version. So we want to be able to package our Node.js apps with a specific version of Node. So at like face value, this looks awesome. If you go onto the public registries, if you go into the public registry, you can see there's 0.10.38, 12.2, and 0.8.28. Those are the versions of Node that exist in the public registry. But when they publish these versions, they don't throw away the old tags. So the old tags still exist. So they're there on the registry. So I can still run Docker, so I can still go over to here and do Docker run Node 0.12.0 node-v. And then that last command is a command that I'm sending into the Docker container. So when I run that, you can see it spun up, it ran Node. I can get a little prompt here. So I can do version pinning just fine. Oh, it helps if I make it interactive. Yeah. So I can do version pinning just fine. Okay, so version pinning works, and then I can run the latest version, and it works. That's great and all. But the problem with this is when they publish the new versions, and I may not have pulled it up here before I started my talk, and that's fine. They publish it to what's called, I think it's not a manifest file. It's a definition that actually like points to a GitHub location, a very specific branch, and it says, hey, this is what we want, this Docker file is what we want to be in the official images. And when they do that, all they do is they delete, when they update to like 10.39, or yeah, 10.39, they'll throw away 10.38 from that file, and they'll put 0.39. So from that point forward, 0.38 will no longer be built. So if I'm from a production side of things, and I want to, push out a version of 10.38 6 months from now, because that's what we're still on internally, I'm going to be deploying an entire stack that was starting to go stale as of today. That's scary. So what does that look like? So I've actually run those two commands. I've run apt-get update and apt-get update and apt-get upgrade on these two different versions of Node. It says 12.2, the most recent. When you scroll down, there have been, I think 9 updates since that was released for Ubuntu. And those may have been released because this imports from build packs Jesse on the public registry. So it may be that that's not the most recent version of Debian out there with the most recent version of Debian packages. But there's 9 upgrades for this as of today. For 12.0, there's 84. So as we're progressing, things are getting more and more and more stale. And you can always easily run apt-get update at a layer above this later on downstream, but that's making a very large image because you're deleting files and creating files, and things are getting very large at that point because of the AUFS. And what's even more concerning is that we're not actually getting any if convention changes between now and when whatever day it is that you're deciding that you're going to deploy your application. And the best way of deploying Node or installing Node on one of these machines, you're not going to get that on your pin version. So these are no longer maintained versions. They're entirely stale versions that are still out there on the registry. So what my solution to this is right now is not a pretty solution, but it does allow us to do version pinning, and allows us to do version pinning on a very well-maintained code base. And this does 2 things, for at least what my use case was, which is allows me to do version pinning to specific versions of Node, and it acts as a definitive way to install Node and IO.js from the NodeSource repository. So if somebody says, hey, how do I do version pinning, which we get those questions all the time on our GitHub, I can just say, hey, look at this Docker file. It'll show you all the commands that you need to run in order to get Node.js properly installed the way we recommend doing it. So what does this file look like? So when you compare this, which is the single Node repository for the official, the official Node Docker images. This is what their page looks like, and this is the one image that they distribute. On the NodeSource repository, you can see we have a proper image maintained for Wheezy, Fedora 20 and 21, CentOS 7 and 6. We don't provide 5 right now. Oh no, we do provide 5. We got EPL working. Utopic, Trusty, Precise, Sid, Jesse, and we have a legacy version of Node where we didn't do version pinning. That was my first go with these things. It's now depreciated. So these act as definitive ways of installing our repos on these images. And I've created, so the Docker files, this distribution, which is a JavaScript definition of all the images that we're going to maintain. And we have a script that imports this and determines which Docker files it's going to build and how it's going to build those. So I define each version or permutation of Node that we're going to support on each distribution and release of an operating system, along with whether it's Node or IOJS and the version of that. And then if there's anything outside of the norm, I capture that inside of here. But quite a few versions, or not versions, but quite a few images that we're going to build. So we run generate.js, and it creates all of these Docker files. The Docker files store templates, or the Docker file templates are stored in Docker files, the Docker files folder. We basically have raw strings that tell you where you're going to insert things, because on Ubuntu, installing Node.js is the same on Jesse, Sid, as it is on Wheezy. From our repositories, you curl down the .dev and install it. And the same goes for CentOS, et cetera, et cetera. Yeah, but at the end of the day, do a find. This creates 104 images that I'm now maintaining in order to allow version bin across different operating systems. This may not be the most effective, and if you're holding things, like if you're doing this internally, you probably will get to choose which operating system you're targeting. So it wouldn't be just like Fedora 20 or Fedora 21, depending on what your security team tells you. You're probably going to just pick one of these, so you'll probably only be maintaining 30 or 32 images max. But like for what we're doing and what we're trying to accomplish, I've created 104 IOJS images are going to be released for Fedora and CentOS soon, which will be fun, because now that'll probably double the number I'm maintaining again. But yeah, this is where we're at right now with my solution to taking ownership of the stack as a developer and allowing version pinning of Node. So yeah, this concludes most of what I had formalized. Questions, comments, discussions, cheap shots, feel free.
How many containers does it take to run example application?
It depends on what you're shooting for. Docker's best practice is to have one service per container. So it depends on your dependencies at that point.
What about persistence?
Persistence, it depends.
Like MySQL.
Yeah, so MySQL, when you deploy a MySQL container, you can mount in a volume for all of its files, and you mount that to your local directory. So wherever you're wanting to store that, and you store that on your local host and allow the container access to that to write all of its persistence files.
So basically you have a single Docker container for a persistent service, and then 20 other containers can share access that to access the data.
Actually, that's one of the best practices, is if you need a lot of, if you need like a large number of files and you don't want to capture those in a Docker container, you can actually spin up a data volume, or data container, I think is what they call. It's outside of the scope of anything I've ever worked on, but you can do that. The other thing you can do is what I do here. Let's see if I can go into Docker Echo. Let's see that B, so Docker Echo. NPM or Docker run. Yeah. So I actually mount my current working directory in production, I'll take my current working directory and I'll mount it as /var/log inside of Docker ICO. And inside of that is where I'll store all of my persistence. So I have a few flat file databases that I use that are just maintained from Node.js. So there's no actual service running for it. They all get dropped into /var or /log along with Docker ICO.log, which contains all of the error messages and everything like that. So I can access those from outside the container. Yeah.
I was thinking more like a web app where you got a MySQL server.
Right.
And then you can spawn 5 or 100 containers to service the users.
Right.
You know, what's the best practice in terms of sharing that MySQL database?
Oh, so, okay, different. Okay, so if you have like a bunch of containers all talking to a single MySQL database. Right. So that MySQL database can actually be done 2 ways. If that MySQL database is on a different host than all of your client containers, you'll just do normal practice of connecting to a port. The other thing you can do is you can actually do container linking so that you only expose an internal port of one Docker container to containers it's linked to. So you can actually spin up those client containers and they will only be able to talk to that MySQL database and nothing from the outside world can get to that database. So you reduce the attack surface of that MySQL
Yeah,
database.
it's just behind whatever your firewall is anyway.
Right, well, yeah, and if somebody manages to get into there, they still have to get
So
through.
basically,
They have to get onto the host and then into the container.
one way to do it would be to set up a persistent container within MySQL environment, and he exposes 3306 and any other container.
Right, and then a good idea would still be, unless you're just using it for caching, to mount a volume where you store that stuff on your host. Otherwise, when that container disappears, everything inside of the containers are not persistent. If you shut down and kill and clean up a container, the next time you deploy an image, that won't have any of the changes that happen in that container unless you committed them.
Yeah, and then no problem. I was thinking more contention issues like you can't launch 2 MySQL containers against the same volume.
Right. Well, yeah, depends on if.
Good.
It depends on the service. If it expects exclusive access, no, you can't. But,
Thanks.
So I look at Docker and I see a good potential for front-end websites, small applications. But when I look at enterprise applications, I still don't quite see a solution here. So if I'm looking, we'll use Jenkins for an example. I can see spinning up Jenkins in Docker and deploying it out.
well, it depends. Jenkins is its own little beast because it runs on the JVM. And JVM is pretty much standardized in the way you run it. But configuring, setting up, and doing all the persistence around Jenkins is really, really easy in Docker. Actually, I prefer deploying Jenkins via Docker because I can create a configuration folder mounted via volume, put all my persistent files in that one folder, and I can create a private GitHub repository where I commit those. Probably not ideal for enterprise, but if you have an internal version control system that's secure, you can commit your Jenkins configuration in a single folder or single directory, and next time like Jenkins crashes or decides that it's consuming too much memory on the host and it needs to shut itself down because it's scared, like you can just spin up another Jenkins container, have it pull that down, and it'll just start up like nothing. So that's pretty awesome.
Build slaves. You can just spin up a bunch of slaves and do builds.
Yeah, well, scaling Jenkins out that way, but the master can do its own little persistence where it starts up real quick. And then you only have to deal with Jenkins startup. You don't have to deal with the host startup or virtual machine startup. But running bare metal, if it's the only thing there, there's no difference. But in a container environment, you can limit resources if you decide to do that. So you can say you can use up to 512 megabytes of RAM, but no more. But you're not getting exclusive access to that. But I guess it depends on how you're deploying.
So I'm trying to fit all this into like the good old Eagles, Apache or Linux setup. Say I have one server and I have 100 websites running on that Eagles. How would I go about using Docker to solve that problem with like one server?
So you have one server, many websites, all being
website, and each one of them would run like containers.
So each website running its own, is it all being maintained by its own Apache instance, or is it one instance of Apache serving all of them?
I think That's
Probably the second one. I'm guessing if it's virtual host, it'd be one Apache with
right.
lots of
Well,
sites.
ideally, yes, but there is a reverse proxy image out there for Nginx, not Apache, that what it'll do is it'll work with that in Docker-Gen, to where when you launch new containers that are virtual hosts, what it'll do is it'll spin up one Nginx image or container, and then it'll automatically see that you've got these other hosts that have been deployed as containers, and it'll actually reload the configuration of Nginx to reverse proxy back to those based on the virtual host name. So there's some stuff out there for that. Apache, I'm not so sure about, but at least for Nginx, yes.
Right, so you can just proxy tab.
Yeah, it just proxy pass based on the virtual host, and what it does is whenever it sees that a new container has been spun up that is a virtual host, it'll rewrite, Docker-Gen will rewrite the Nginx config and cause that config to be reloaded.
Is there a use case?
Sorry, your question's better.
What's the desktop, developer working on the desktop, what's the use case there? Are they developing in IntelliJ, doing some type of build to point to like a whole Docker instance? Or is there a use case there other than configuration of the Docker image?
There's a few people who use Docker full time for their development. So like they're whether it be Node.js or what have you, they run just about everything through Docker, because when they're done developing, none of those resources are left over on their computer. So you basically throw the container away and you don't have to worry about cleanup. Where if you apt-get install something, even if you do a purge, it's all left behind. I was watching a talk today by Jessie, I think her name was, the Mad Hatter of Docker containers. And she basically runs Chrome in a container. She runs, I think she had LibreOffice running in a container. She has Steam running in a container. Basically everything on her desktop. The only thing she has running in user space or in kernel space on the actual server is X11, and she just bind mounts in the socket. So that when she's done with it, she can just throw away the container and she doesn't have to worry about the cleanup afterward. So that's a use case. And then the other one is configuration across the teams. So if you have a very specific configuration for your Nginx server or your Apache server, and you need that for development and that's a requirement, instead of having this long list of you need to import this configuration file or whatnot, you just spin up a single configuration file or a single Docker container, mount in your code base and as a volume, and it'll run that for you.
Just to throw in out there, I was reading an article that was linked out to CenturyLinkLabs.com about remote pairing for the developers. So they had set up their development environment and were doing remote pairing with the other developers within CenturyLink Labs, using the Docker containers. It was kind of interesting to try to get a better idea how they were using it. Still, some of the parts went over my head.
I haven't heard of that. You said it was CenturyLink?
CenturyLink Labs.
Former status?
Yeah, that's still the status open source labs. So they kind of spun up into a different org and have been working pretty heavy on different concepts for Docker.
Yeah.
Okay. I use Windows, so I'm very new to trying to get like Linux type packages, but without having to run on top of Linux. The recent thing I did was Vagrant, and I'm just barely getting to where I understand what's going on with that. So how would you compare this to Vagrant as far as like running it on a Windows computer or something like that? Would it work?
So Docker has really great Windows support through virtual machine. So what it does is it's called boot to Docker. It's a very, very tiny virtual machine image that spins up the entire Docker, like just basically just enough to get Docker off the ground and run containers. And then it does all the port forwarding on that virtual machine for you. So basically you'll have the Docker CLI running on the Windows side of things, and all the commands get forwarded into the virtual machine where the changes take place and the ports get exposed out of the virtual machine and onto the local host.
So I would like SSH into the Docker virtual machine.
There would be no need to SSH, I don't think. I know on Mac, at least, all the commands are sent into the virtual machine from the Mac's terminal. I'm pretty sure the same thing happens on Windows, but
Yes, it is.
it does. So yeah, so it'll all just
As a regular command prompt.
type your stuff in.
You just have to expose your port to that virtual machine.
It's called Boot to Docker. Check it out. It's really awesome. Yes.
So what are you using on the Mac? PC user, if you're running Linux on there?
This is a straight version of Debian that I've installed Awesome Window Manager on top of. Yeah.
And can you go back to when you spin up those containers on the terminal? I just wondering.
Which one?
This one.
This one?
Yeah. What is like on the top of that?
Oh, that's HTOP.
What is it?
So it's HTOP. It's like top, but not ugly. Yes.
Better than top.
Exactly. Yeah, it's top with my terminal has the Molokai color scheme on it. Molokai, the Hawaiian island. Yeah, I got that color scheme to match my bin.
It's just a system monitor, so you can see.
Yeah, it's resources.
CPU usage.
So if I run like a boot, can I do just apt-get HTOP?
Yeah.
Is that what it is?
Yep, and then you type HTOP and it spins up. So. And then the reason for that was when I ran gimmick 1.sh. Oh, it helps if I actually pass in the number. When I ran that, you could see the resources climbing, and if I was spinning up virtual machines, you'd be seeing huge chunks of RAM disappearing each time one of those started. And with this, like, it was just slowly climbing. Like Chrome used more memory than all 25 instances of Mongo did, all in their own little containers.
Sorry, I have so many questions.
No. We have plenty of time before.
So like I said, like what our server stack right now is DevOps, and Docker has changed everything. It's more like a microservice kind of stuff. So what's the best practice, say if I have a company or service stack that I'm running, would I be better to launch a web app per server instance or launching different containers on one server?
It depends on what you're after. With Apache, I'm not sure if I'm the best one to talk or speak to Apache. It's been years since I've used it. But yeah.
I will say, if you are thinking about redundancy, right, even though you're running multiple containers on a single server, if that thing trips over a cord or if that machine goes down, if you've got everything on one server, you don't have any redundancy, right? So it might be worthwhile to think about splitting up, maybe you've got 4 servers and you split up the containers across those 4 servers as opposed to loading it all up on one.
Gotcha.
Having a different site per container would give you some, if one site gets hit, gets slashed out or whatever, it gives you, a way to manage.
There's different tools out there to set up clusters. You can set up a cluster on one machine, cluster on another machine, cluster in New England, cluster in LA. And then your balancer will distribute based on georeferencing.
Right.
A is faster for closer, but the cluster topology is much better for high availability.
You do want redundancy. I totally agree with you.
Oh,
You want more than one, so.
right.
Yes.
More than one physical environment.
Yes.
If you're doing like a website, would you keep all your www files on something that doesn't change that much, and then use these Docker containers to upgrade like the Nginx server, or would you deploy those as part of a Docker's spin up thing?
So it depends. If you want your website to be persistent, persist in the public registry, you can create a data container that contains your website and maybe link that into another container, like a data container specifically for that. And then all of your other containers necessary to run the rest of your stack, put them in other containers, like there'd be like Apache and MySQL, have those in their own separate containers, and then have a Docker compose script start those. But honestly, if they're just starting out with Docker, feel free to throw everything into the same container while you figure it out. there's no best practice when you're starting out. Just like start doing the best practices later. Just right now, we're
For a practical standpoint, no company's going to be using a public repository. So it's my understanding that basically repository is just to get server. You can set your own up in the company trivially in 5 minutes. And the process works the same whether you pull them from GitHub or Intune.
It works similar. I mean, the way you have to address public or private repositories is a little different, but it's still a Docker pull. You're just telling Docker where it's pulling from. A little bit similar. Yeah. I've been meaning to do that. But Artifactory, I think, actually, if you use Artifactory internally, Artifactory has Docker registry built in. So as an NPM registry built in. Yeah.
I'm a big fan of KISS. If it's a good server, I want to get server. I don't want to put 20 different names on it.
Yeah.
Did you see you graduated from Carbondale in 22 days?
Yes.
So I'm not expecting it depends, but computer science, Carbondale or Edwards?
I have very little experience with our Edwards program other than the single student who attended one of the hackathons I hosted in Carbondale, and he seemed to be just fine. So I just say study computer science. I guess backtrack, better answer, the internet. Just doesn't matter where you're going, just do something outside the box.
Historically, Carbondale has always been students are protected. Operating lower level, hardware hackers, assembly level programmers 20 years ago. Whereas Edwards has always been the IT side, the business side, and that. It may have changed over the years, but I don't know if that's helps your perspective or not.
We've got a lot of great seniors graduating this year, so that's all I can speak to. A lot of my friends are very capable, and they're more capable than a lot of the people I've been seeing graduating out of SIU. It's a good year for SIU.
It's almost interesting. There's two different worlds. 99.995% of the public thinks IT is setting up an accounting system for a corporation, and that's computer science. So what are you gonna do after graduation?
We want to start doing this full time.
Really?
Yeah, I do this 20 hours a month. I've been doing that for 8 months now, 20 hours a month. Cool. So it's a little bit of progress, but once I start going like 40 hours a week and then doing it as a hobby, also start seeing a lot more results than what I had to show today.
So some people might have something to say about that.
What do you do besides playing with Docker and school?
Word of wisdom, spend at least 15 minutes a day looking at the better half.
Well, this is 30 seconds.
You don't have to answer.
No, literally, this isn't work for me. It's a hobby, and it just so happens like I've interned with Boeing. And I've done a lot of really cool programming gigs in my day, and like every time I got a new gig that I was working on, people would like tell me talk to me like how's work, and the answer is always like this isn't work. Like, I'm getting paid to do stuff I would do for free. Like, this is a good.
Well, that's fine, right?
Yeah.
Do you have any comments on Heroku or Masons?
I use Heroku. I actually have, it would be a disservice to the term production to call it a production app. But I'm running an application on Heroku right now, and if you want to bootstrap an application, like it's a great way to do it.
Oh, can you talk about DigitalOcean? Is like Docker specifically for DigitalOcean?
It runs great on DigitalOcean, but it's not specifically for DigitalOcean.
I see a whale and I see an ocean.
There's a lot of parallels.
That's awesome.
Well, that's where Docker ICO runs, is DigitalOcean. That's also where Docker ICO, I'm a broke college student, so I can afford one server a month. That's where the monitoring services for Docker ICO sits, and Docker ICO's redundancy sits all on the same servers. If it ever falls off the face of the earth, Docker ICO's in trouble.
What was that again? The Docker.
Docker I.co. So that's the
Docker.
Yeah, it's somewhere around here. It's that little badging service.
.i.co.
Yeah, so it allows you to take, well, if you're fancy, and that's the like 13 stars, 6,000 downloads, and 2 comments is for our depreciated repo.
Is that a local, is Docker local to this area?
Mm-hmm.
Or you just work remotely?
I work remote, but I work for a company called NodeSource. We do like consulting for Node.js.
Okay, this could be a question for everyone.
Thank you.
So like, as you say, DigitalOcean, say you run Docker and you are solely responsible for your own server and all that stuff. So that's personal projects or application that you're running. But if you work for someone and you're as a developer running an application and you're using a hosting service from enterprise level companies, how you manage to pushing the application up to that server and have expectation of like security on that server and all that stuff. Like how we finding that balance between being a developer and system.
Well, you either have to do it yourself or open your wallet.
What's that?
You'd have to do it yourself or open your wallet.
Yeah, I think at that point, you probably want to enter, when you look at enterprise, enter into a managed services, you get a managed server, so you have people at least run the OS. And then on top of there, you would just manage the orchestration and automation. So in this example, you might use Foreman to help with some of the automation and orchestration on there. And then kind of rely on the managed services guys to help secure OS level stuff and virtualize the infrastructure.
Right.
I heard there were still issues with container isolation. That
Pre 1 point, I think it was pre 1.0. People were able to escape from, or people were able to escape from the container, but there's nothing on the current version that says it.
I think that was one of those battles, just saying with virtualization and hypervisors that we'll always probably fight. To me, it's always been a matter of, is it really feasible? It's always probably possible to break through whatever hypervisor or virtualization you have, but is it really feasible? I mean, I think Docker will eventually reach the same point. It's still, to me, very early to look at enterprise level applications, but small, medium business applications, it looks pretty ripe for it. But I think that security wise, you're still going to fight that concept of, how can you prove that it's impenetrable or, you can't escape out. I think that's just.
Well, 30 seconds before the test, we show we're full network here. Virtually or physically.
That was kind of the talk of the week, I guess, right? Related to owning your stack. You
Yeah.
start from the Debbie and Jesse face image. Who's to say where that came from and who built it and how it built? So.
Very true. It was a good article. Yeah, it was a good article that went around about that, actually.
Oh, the trusted images. I remember that they found a way to trick it into downloading images that weren't really legitimate, running fair images.
Well, it's like when you throw something down and you just pipe it right in the shell.
Oh, that's awesome.
Like, if people don't go look to see what's
It's
going on.
2015 and we still do this.
Sure,
So
sure.
trusting.
That's why you keep your images in your own repository and no user has right access.
But even then, like man-in-the-middle attacks, they were able to like or trick you into downloading a trusted container. They have signing for them now, but it's still a
Yeah, but see, no production environment would download your image from an outside source.
That just comes back to cost of it. I mean, out of all the operations I work, DoD is the only operation I've ever seen that actually is looking at the software level to make sure what they're bringing in is actually what they're bringing in. I know working with Snyder, APC, even at the Century, like, we don't have to look at that level. It's just too much time and money. This is some cost. You're never going to see a return on it. Just high hopes that it was something good and trusted.
But the simple fix for escaping a container is that the UID is being issued from your kernel. So the UID inside the container is going to be the UID outside the container, or escape. So if you're root in the container, you're going to be root outside the container. If you're user 21 in the container, you're going to be user 21 outside the container. So if you set your user ID to 20,000 and that doesn't exist outside the container, in the escape, you're going to be some nameless user with no read-write access to anything. So
Of course, 99.9999 is pretty much for nobody.
Yeah, maybe.
Does Docker daemon still require some privileges?
Docker daemon, yeah, so if you can talk to the daemon, but the daemon isn't actually running, the daemon is just orchestrating things.
Right.
So if you can get the daemon to do things, yes, so any user that has access to the daemon does have access to root operations on the operating system. So yeah, it would, right. But that's outside the container.
Is this really concern for an enterprise level for internal applications, or the security concerns with Docker? I mean, if they say they still existed, does it matter if your applications are internal? This really becomes a problem if you're on a shared cloud.
I
Would say enterprise operations, your largest threat's coming from internal, it's not coming from external. I mean, you're looking, especially if you're looking at a company with more than 20 or 30,000 employees. At that point, your largest, more or less, threat is going to be from inside, whether it's external threat found a way through one of your end users. That's primary vector, most common.
Sony.
Right, yeah. Sony, MasterCard,
Yeah.
Citibank.
Yeah.
Most of those, the finance guys normally use on their DB side for different white space issues and not securing some of their sites. And then the end user factor still, you get that many employees globally distributed under different compliances. That's going to be your primary factor, I think, at that level.
Okay, I have another beginner question. Okay, so I just made 25 Mongo whatever EVs.
Yeah.
So two things. I want to upgrade the container. You said it pushes the Delta. Is that like compiled stuff or source stuff and it compiles it itself?
Those are the changes on your file system. So like, for example, the very simple example would be like, let's say I have the container and my update was actually creating a very so basically I take the container that already existed and all I do is I added a new command to the very bottom. So maybe that's apt-get update, although you usually aren't supposed to run those in your containers unless it's the very end of the chain. So apt-get update, apt-get upgrade, and you update everything, right? All the files that were deleted and added in that operation, that's all you're sending across. So instead of taking the disk image for a virtual machine, it's like 20 gigabytes and doing the update there and then resending out that disk image across the network to everybody that wants to run it. All you're doing is you're sending out the file changes that change, okay? And all downstream effects that it had.
And you can do all 20 of those containers at one time. Like you don't have to target container 1, push the Delta container 2.
No, so what happens is when you go to Docker, like do Docker run, it'll periodically check the registry to see if there's a new version. So it won't update containers that are running. So you have to physically check to see if there's an update, pull it down. So like run Docker pull, see if there's an update, if there's an update. Docker ICO has its INIT script. It has I added an update, so I do /etc initd Docker ICO updates, and it updates and then restarts the container.
And basically, when you instantiate a container, he looks at the repository and says, is it the same version that he has? If so, run it. If not, he pulls the new version from the repository.
Okay.
That's the simplest way to think of it. Because you're not actually pushing an update to the container, you're putting those updates in the repository, and then either you force an update or instantiate a new container, things that you do.
And then you identify the, let's say I'm in command line, how do I know which container I'm going into local or is it?
So you can't actually enter containers without special tools.
Okay.
So like you can actually, there's like nsenter, which you can actually install via Docker. So you pull down a Docker image and we'll build it, compile it on your system and install it. But you can actually spin up another process inside of a Docker container that's currently running. And that lets you enter that container. So you can like start up a batch, which will give you an interactive batch from inside of the container. But they require special tooling.
You should show the actual build process because that really codifies like each run is a layer, and so you can see where the deltas are coming from. I think it's probably one of the more interesting things.
// Debian, Jesse, Node.js. 6.2. So in this, if I do a Docker build, the first thing it does is it uploads the context, so the entire working directory, layer by layer. You can see that first one, maintainer William Blankenship, first line. Or well, from hold on. Updates. Oh, I don't have internet. No, you're right. This is whatever.
Thank you.
I have one job. You want to?
Yeah, go ahead.
Yes.
Right,
Did you
go
find
fast.
any?
We'll
yes,
see how this actually
yes,
works.
Yes.
Yes?
Yes, that's great. It's BE and IMBLE.
Oh, no. Sorry. WPA. Passphrase. What is it?
BE and IMBLE, all lowercase.
BENIMBLE.
MBLE.
That's it?
E nimble with an E.
Oh.
E.
Oh, with an E. E. Okay.
There you go, that's it.
Okay. Let's see if Linux likes it. Cool. There we go.
That looks better.
So yeah, now it's going to create these layer by layer and commit them. All the deltas that happen between the layers will be tarred up.
Yeah, it makes a lot more sense to think it's pointing from a repository and that sort of thing. That makes a lot more sense.
And what's nice is when you do this, it caches locally those layers, so you don't change any lower layers. When you go to rebuild that image, it's already there. Layer.
Sure. When on Docker ICO, it's running on a Debian on Ubuntu, which has Substack and start times for the Docker images, and it's running with Node, and Node just like quick starts, and so fast fail, quick starts. I can do an update where I Docker pull, and then I'll restart the container, and there's no apparent change to the end user. So I have a bunch of monitors running on it, and none of them ever catch the update. This Docker is able to shut down and run it. How often do I run updates?
How often do the RP checks go?
Usually the quickest one I think is half second, but so less than half second.
Milliseconds.
There are a lot of milliseconds, yes, but for something that's rendering SVGs on GitHub, it's not horrible.
You too can get paid to watch Docker containers build.
Awesome.
It's a huge joke, but that's part of my job.
Have you ever sat there and watched the build just
Or with the drink in one hand.
I think there's an XKCD for that. Yes.
Try to do a Linux from scratch system once a year just for good practice and find out getting more intoxicated before it finishes. Each time.
Kernel violence.
I love your point about how, like, the whole decision process is kind of moving from, sysadmin, this is what we've decided to use, and it's kind of more distributed now. So that's huge.
Yeah, and I think one thing I left out that's in the blog post is that, like, the sysadmin, when you bring up the sysadmin, they're expertise on configuring these services are still extremely valuable. But
Yeah.
instead of it being some archaic knowledge where it's deployed on a server somewhere, and next time that server goes down and they decide they're going to throw that one away and redeploy somewhere else, like he uses archaic knowledge again to create a new one. It's captured as a pull request against the Docker file that your developers are maintaining. So your developers decide we're going to use this, this, and this, and then your sysadmin can come in and say you're doing this wrong, and they can do a pull request against it, and now that's captured. And your developers see the pull request, they look to it, okay, this makes sense. And your sysadmin now only has to do that once, as opposed to doing that all the time. And now he can go back to focusing on making sure developers are happy moving their code into production safely.
Yeah, it's shared knowledge, like instead of like incantations to make things happen.
Yeah. How do you sync up what's going to build versus what's in your container? So I might have if I'm using Node, whatever, 1 point whatever, for my, to build the map, right? Is there an easy way to sync up check that against what's being done for building my container? Or is it a manual process of, I go compare the versions of Node? Does that make any sense?
I'm not following.
So your node install is going to be encapsulated in your image as a layer. So whenever you run that container, it's going to use whatever's in the file system, right? So if you build your image with, say, Node 10.338, whatever's the latest .10, right? Like that's going to be frozen in that image. So whenever you run anything within that container, that's going to be using that set of Node because those binaries are there on the library files. Does that make sense? Like as far as your validation? Because when you were running spin up a container, you're just doing Node V to pull out the version.
I know what you're saying. That's a scenario where I'm running it on, where I'm running it in that container. But if you have CI that possibly builds things separately, you're pulling a war file into that container.
Well, the idea would be CI would go in.
CI shouldn't modify the base container. So that image, that it pulled down, it's never going to make changes to that image that will be shipped to production.
But if my CI builds my war separate from my container, how do I verify that that war file matches with the things used to build that war file match up to that container?
Do you know anybody using Tomcat or any other application servers, JBoss, with Docker? See, I don't know anybody using any application containers. Most of the people that are deploying JVM bits that I'm aware of are open like Jetty or Netty or things where the HTTP adapters and other bits are embedded right in. So you just spin it up and hook it up to a load balancer. I'm not sure how people are doing wars, but I'd imagine you'd still be building your war separately, but then you need to have that put into another job with Jenkins that's got the container running that has that volume and stuff, that war in it, so that you can run through your integration tests on top of that.
And in that scenario, if you're using Tomcat, I think you want to enable a Tomcat manager so you can see your actual works. But say if we're looking at some different total, right, Cold Fusion app that you're pointing out, right? So that sounds like a great idea. I had one discussion with one of the base developers, and they're still using Cold Fusion. Of course, that's an argument and stuff. That case, I would think you'd actually want to develop something within your code where you have some way of being able to validate versions somewhere. But on the same side, you can do a list of what files are inside of the Docker container, right? Is that possible?
Oh, sorry.
Yeah. Is there a way to actually list what files, the actual file names within the container?
So if you do a Docker run, like once the container image is built, you can just do an ls.
Exactly inside the container.
Yeah, you do any sort of the execution inside the manifest or a find to list everything.
Yeah, that's still manual.
I mean, you can automate that though, and your CI bash script can do that for you, and then you can do that against the expected output, do a diff against it.
But in your environment, war just like any other application code. And I would think that adding it to that repository for the Docker, would give you a check and balance, because when you instantiate the Docker, you get the image from the repository. And you always know what image that is. So basically, your repository, testing is 1.0, production is 0.9. Once you tested 1.0, then you upgrade the production container from 1.9 to 1.0. And then the next time you instantiate a production container, you get the WAR from that version.
Which I think that makes sense, like if you're doing Tomcat just running for a single war, but what about if I've got the JBoss set up and I've got, different wars and I'm deploying and pulling in and out? Servers that have got multiple tenants, right? That's where I think that gets a little bit hairier, because then you're kind of ship a new image for whatever any one of those needs to make a change or whatever. But I think, yeah, that makes sense as far as just validating a single war with a single.
Well, I'm just speaking of any file system of application code, but I'm not sure that there is I haven't heard a lot of Java stuff on Docker, because it's kind of like apples and oranges. Docker are for small, efficient applications. Java is never small or efficient.
But it is coming.
I mean, that's what I'm very curious, because, looking at enterprise applications, I'm looking at a lot of applications that, my particular client pays a shitload of money for, and they're not utilizing resources. I see an opportunity here, but at the same time, I'm going to throw this fat, heavy Java application that they're custom developing every week and turning over new provisions to, which would make this great for them, speeds up their deployment process, but at the same time, is it going to be able, what kind of ways it can validate the code, these different types of questions, validate, is it going to explode? Am I going to be aware when it shits the bed? Or is it going to be something that blindly, what kind of oddities are going to occur? So I'm with you on the curiosity, like how these larger Java apps going to run inside. And they have to be able to run inside here, otherwise it's never going to reach the enterprise market, because we're working with 10-year-old applications that are still built in Java.
Cubic looks great inside of containers.
Yeah.
I deploy Jenkins inside of Docker. So
It seems like it. My next test on there is I try Atlassian applications and see how that works.
I run Elastic Cloud inside of the container too. Not that is the same thing, or Elasticsearch, not Elastic Cloud. But it behaves exactly the same as running two Java applications on the same bare metal host. As we deploy both of them, and they both decide that they're going to be large, as one crashes and burns complaining because it's scared or something. But it's the same as if you ran them both inside the same machine. But if you want to maintain an SLA where you guarantee that Jenkins will always have 1 GB of RAM, Docker may not be the best way to do that. You want to run that on a non-shared environment, where it's guaranteed those resources are pre-allocated for it. But for most applications, that's not necessary. JVM crashes and doesn't have the exact resources. But there are a lot of applications that can keep chugging along.
Have you seen, so you're saying run the Jenkins master on a non-shared environment. Have you seen people running the agents on that shared environment?
I run Jenkins on a shared environment. I run Monet. I'm fairly confident as JVM.
The agents. So are you dynamically spinning up agents, or you just have them deploy it?
I just deploy them. I deploy it by hand. I don't have anything aerodynamic on the explosion right now.
I think there's a Jenkins plugin that can do that, or can help you with that.
That'd be pretty advantageous.
So what?
That seems like it'd be pretty advantageous.
Yeah, to dynamically spin up those agents and then.
I know when these guys used CI, they only had one build that consumed a lot, so I never wanted to give them a lot of resources. So for once a month, I'd schedule we would go resize the VM so they could get through that build in less than a day or two. So something like that.
And things like Selenium testing that take a long time, have those dynamically scale and then claim them.
You can definitely spin up slaves for that.
Yeah.
If you can set up that architecture perfectly suited in Docker, the whole basic concept is you instantiate that container from a repository, you do your work, you throw the container away, and then you grab another one when you need it.
Yeah.
And you never have to worry about changes in the container. Unless you need to physically push them upstream. But typically you're doing that from someone else. You never know.
I forgot I was broadcasting. I apologize. This is probably distracting. Heroku, all of Heroku apps, those dynos, they're containers. If they support Java, not databases, what am I doing here? Back. There's one else. Oh, the browser's too large, that's why. There we go, there's the plus. Okay. Non-dashboard. Does anybody know how to get to the Heroku homepage from? Aha. Does Heroku support Java? I've never tried to deploy it.
I didn't think so.
Oh well, regardless, if it helps any, Heroku is.
How much do they charge in a dyno these days?
What's that?
How much do they charge for a dyno these days?
Free first.
Yeah.
A lot.
Cool. Cool. I thank you very much, Phil. That was really, really awesome.
Thank you.
It
Thank you
was
for hosting.
fantastic. Best of luck to you in your 23 days left.
Thank you.
Not to greener pastures. Feel free to stick around. There's probably more beer in the fridge, and we can all chat more informally. I am always looking for speakers. So if you have any ideas, let me know. I'm happy to go hunt down sources. Or if you have a good idea for a talk, let me know. All right. Thank you very much.
Thank you.